Divisibility test. Jack's gallbladders collected a mass of 12 gallstones. Determine the prime number of gallstones that the mass can be divided by. So to answer this question, we need a couple of quick tricks or divisibility tests. That we can use to determine if the number can be divided by a smaller number. So divisibility tests are 2. It can be divided by 2 when the last digit is even. So think of it when it ends in 0, 2, 4, 6, or 8. Then 3, if it can be divided by 3 when the sum of the digits is divisible by 3. So this is kind of like 21. So 21, we would add the digits together, so 2 and the 1, which equals 3. Then 3 can be divided by 3 because that equals 1. So we would say 21 is divisible by 3. Then 5, it can be divided by 5 when the last digit is a 0 or a 5. And then for numbers like 7, 11, 13, 17, and 19, we're going to use long division. So now let's go back to our example. So we have 12. So let's go over our divisibility test. So 2. So 2 is yes. This is because 12 ends with an even number. Now we look at 3. So we got 1 plus 2, which is equal to 3. And 3 can be divided by 3, which equals 1. So 3 also checks out. Now we look at 5. So this does not work. 12 does not end with a 0 or 5. Then we can look at 7. But 7 doesn't go into 12. It goes into 14, which is pretty close, but not quite. So this one does not work. So we would say 2 and 3 are the prime numbers that can go into 12. So let's look at another example. Example 2. 2,730 is divisible by which prime numbers? So to answer this question, let's go over our divisibility tests. So we have 2. So this checks out because 2730 ends with a even number, which is the 0. 3. So we would add 2 plus 7 plus 3 plus 0, which is equal to 12. Then we would divide by 3 and see if this is plausible, which 12 divided by 3 is equal to 4. So this checks out because we know that it can be divided by 3. So now we look at 5. Now this also checks out because 2730 ends with 0. So anytime it ends in a 0 or 5, it checks out. Then we look at 7. But for that we need to use long division. So what we're going to do first is we're going to take the number 2,730 and start dividing it. So we're going to divide by 2 first. So 2 can go into 2 one time. 2 times 1 is 2. We'll subtract, get 0. Bring down that 7. 2 goes into 7 3 times. So now 2 times 3 is 6. minus, so 7 minus 6 is 1. Now we bring down the 3. 2 goes into 13 6 times. So we put 12, and we will subtract. 13 minus 12 is 1. We'll bring down that 0. And now we get 2 goes into 10 5 times. So we got minus 10. And we get 0, which is perfect. So now we have 1365. Let's divide this number by 3. So 3 goes into not 1, but it can go into 13 4 times. 3 times 4 is 12. 13 minus 12, or 3 minus 1 is 1. 1 minus 1 is 0. So now we bring down the 6. So now we have 3 goes into 16 5 times. So 3 times 5 is 15. 6 minus 5 is 1. 1 minus 1 is 0. So we just leave that as 1. Then we bring down that second 5. The first 5. 3 goes into 15 now 5 times. So 3 times 5 is 15. We'll subtract. Now we get 0. 5 goes into 455 how many times? So 4 can't be divided by 5. So 5 can go into 45 then 9 times. So 5 times 9 is 45. So 45 minus 45 is 0. Now we bring down that 5. 5 goes into 5 1 time. So 5 times 1 is 5. Now we subtract and we get 0. So now we look at 91. And the next number we can look at to see if it can be divided by is 7. So 7 can go into 9 1 time. 7 times 1 is 7. Subtract, we get 2. Now we bring down that 1. Now 7 goes into 21 13 times. And 13 is a prime number. So we would say the prime numbers for all of this is this 2, the 3, 5, 7, and 13. So we can also write this out. 2, 3, 5, 7, and 13. These are the prime numbers that can go into this number.